All right, so we're just at about here after 10 o'clock Central Time. We'll go ahead and get started. My name is Michael Hadt. I'm with RLE Technologies. I'm the account manager here in the Midwest. Today, what we're going to talk a little bit more about is really understanding how to leverage WiNG Wireless, our wireless network gateway, to gain better visibility into your building. What the outline today, what we really want to accomplish, a lot of things with wireless is what is RLE's WiNG Wireless, the impact data has on system integrators and service companies as well. I want to touch on specifically the WiNG analog transmitter. It's got a lot of flexibility. I'll show a couple things inside of that. And then I put together a variety of different vertical market examples that our WiNG transmitters have been successfully deployed and really fit inside of a variety of different applications. So I wanted to make sure that we were looking at the entire pie here and not just certain verticals. So that's what we'll cover today. So, why wireless? I read this the other day. I thought it was pretty slick in the sense that we're really leveraging wireless today as an opportunity to take an action. All right. Wireless has historically been very much so desired. It's come with a few challenges in design layout and distances and range and battery life and a variety of others. But RLE's really done a lot to drive that visibility and optimization. So what we'll talk a little bit more about is what data do you really need? Why do you even need it? So if you're going to get the data, what are you going to do with it? Are you going to monitor? Are you going to alarm? Are you trying to create a threshold? Are you trying to leverage system optimization and put in more temperature, humidity, maybe some CO2? Maybe there's a pipe strap sensor. We'll get into a little bit more of that later. But what are you going to do with it? Are you going to tie it into some analytics? Is there a platform that you're currently leveraging for a network of customers to create some visibility and even some compliance reporting? So kind of want to stage it through what do we want to accomplish with it. And then in a lot of cases, the existing infrastructure that's reopening today already exists and already has sensing points. And what I'm really looking at is the opportunity to leverage more of a hybrid approach. RLE's WiNG is compatible with BACnet, Modbus, and SNMP. So in those existing environments where you have a variety of sensors, let's look at a hybrid approach where you can get more data to drive a better outcome. And then, is the other action really because there's an installation savings? I have an example I'll walk through here as well, which created a ton of labor savings, installation savings, and integration savings with our Wi-Fi temp humidity transmitter. And then the other thing you want to look at with wireless is, well, how can I monitor other things after I start here? So I was asked yesterday actually around future proofing. So how do we grow that? How do we integrate and incorporate other data points as well to drive different outcomes? And does the tools have the ability to scale? All right. So, I always generally like to start with an RLE enterprise monitoring network architecture. Because it does a nice job of laying out a variety of the things that we do have to offer to really help, right? Obviously, we're going to talk a little bit more specifically about the WiNG wireless transmitters today and the capability of how it sits on a network. But I didn't want to miss the opportunity to share a little bit more specifically around the F200 and our distance read leak detection. I would call, our F200 more of an edge device. That would reside in typically like a data closet, but I've seen it with system integrators using the temperature probe on hot water pipes, mainly because it's simple to install, it's simple to set up, it's easy to manage, it's easy to integrate, it's got all the user interface that you want as well as the alarming available and some trending. So it really does make a nice compact device to be able to deploy into the market. And quite honestly, let's be honest here. I mean, there's a lot of buildings that aren't going to be used the way that they were previously. So where are those different data closets and where are those different points of sensing that you really require to really maintain a productive environment? And then I put the camera on there mainly to show that we don't sell cameras, but I put it on there mainly to show that there is a relay output on this, as well as a variety of the other controllers that we have that we'll talk about. And, you know, what we want to accomplish is, you know, the overall system integration of how different technologies can merge together. So there was a use case example that I like to share that I worked on with another partner of ours. And what they had done was basically a data closet that was in an old janitor closet, right? So there was some piping, a wash tub. There were some other things in there that probably weren't the most desired place for it, but that's where, you know, space utilization happens. So they ended up putting a camera in there, and instead of having that camera on the network recording 24/7, we were able to leverage the relay output based on a condition, whether it was a leak, whether it was a temperature threshold. There was a door contact that we integrated. We also integrated our power fail monitor. So if power tripped, you know, all of these functions, even a smoke detector and our hydrogen detector, would be able to trip the camera to start recording, right? So we're now impacting another solution to solve another problem with the technology that's there. And to me, that's really what it's all about, is leveraging the technology to drive the greater good. And then on the bottom right there is our distance read leak detection, where, you know, what we're ultimately delivering with our distance read leak detection is protection of your critical spaces. So there's a lot of buildings, a whole variety of them, and I'll talk about a little bit more of them, but they all have piping. They all have hot water cooling towers. They all got boilers. They all got piping to bathrooms and things like that. So let's make sure that, you know, especially with the fewer number of people that are potentially going to be in these spaces, let's make sure the infrastructure is protected as well. I think that's so critical and so important, and sometimes gets lost in the shuffle with everything else that can be accomplished with technology. So, and on the top end there, it's our FMS, facility monitoring solution. It's our enterprise solution, capable of integrating 32 devices, BACnet, Modbus, or SNMP back to it. It's got graphical capabilities. It's got alarming. It's a nice system that has the ability to really drive additional inputs as well, up to 104 digital inputs and inputs as a whole. You can do some analog inputs and relay outputs, so you can do some relay logic, you know, and in some cases, I think I have it in here as well. What we have done is leveraged a variety of these systems to come back to the FMS as the aggregator of this data, to then push out to another DSIM or an enterprise BAS or an IoT system to aggregate that data, to kind of control it, to manage it. IT guys like that a lot. And, you know, they don't always like to have a whole bunch of stuff on their network. So getting into the next slide here. Architecture and design. I know that there's a lot of wireless options out in the marketplace today, and they all have different capabilities and everything like that. And our technology is running on a 900 megahertz system. Our international platform is also going to be an 868 platform. So, you know, when we're talking about a radio transmission, it's not the traditional, a lot of folks know the Zigbee or other things that are going to go hop to hop to hop to hop, you know, to create that network, and you just keep stalling gateways and everything. I mean, or, you know, repeaters. You know, at some point, installing too many repeaters ultimately adds to the cost and the overall job as well, and the headache of it. So, you know, what we're trying to accomplish is really deliver that distance that you need, right? I mean, a typical transmitter line of sight can talk up to 600 feet away from the wing manager or the range extender. Now, we all know we're in these buildings. Rarely are you going to be line of sight. I can confidently say that I have physically seen our transmitters talk 200 feet through a wall, and you know, it's still penetrating those walls and getting through them with that 900 megahertz signal. And you know, when we're looking at the architecture, we're looking at the wing manager, let's say somewhere centrally located in the building, and then putting range extenders on different floors or further out in the different areas of the building, so that we can push that data back to it. So if you think about it, you can go call it just for fun, let's just say 200 feet around the range extender, which could be 800 feet away from the wing manager, and still get that data back to the wing manager and integrate it back into your system. So I know there's a variety of folks that have air handlers on the 3rd floor or 4th floor, or pick your number, right? And their control system is maybe on the 2nd floor, or, you know, you pick your number, right? And so what we're trying to accomplish is really give you that range and capability to drive the outcome that's desired. Because Wing has historically had wireless, I should say, has historically been challenged, again, with the battery life and the range and the distance and the way that it's able to communicate. So what we're trying to do is, again, optimize system performance, especially with all these buildings reopening. There's a good partner of ours that was working on a healthy dashboard. And what they were looking to accomplish was to take some filter status with our differential air pressure, CO2 in the space, temperature, humidity in different spaces, as well as the air handler, to make sure that, you know, what they're producing is really what's required, as well as a pipe strap sensor to make sure that the hot water temperature is 140 degrees. I believe they had told me that anything under 120 degrees was not as effective as burning off viruses and contaminants and things like that. So how many other areas in your building do you have piping that you really don't know what that temperature is and whether or not it's really at the right temperature to be effective, right? So so kudos to those guys for wanting to put together that dashboard and really drive visibility. I think as we're all reopening today, one of the big things that we all want is comfort. We want to be comfortable knowing that the building operator has provided some level of forward steps to produce a safer environment. Now, don't let me fool you, sensing, right? I mean, you still need all the mechanical equipment in that building to actually operate and create that exhaust air, you know, the air changes every hour that now is being looked at inside of traditional buildings instead of historically it was, you know, obviously the operating rooms was the most critical, right? So now we're trying to get all contaminants out all the time, and there's a variety of ways to do it. So we're just looking to provide our insights into some different ways to get you some of that data. When talking about that, you know, one of the big things that we were looking at the other day was what all can we do with our wireless sensors? So I was working with a few folks, and they had said, well, hey, it'd be nice if we had a kind of a clean, common examples layout of what can be done with these different transmitters. Now, obviously, these aren't all the examples that are possible, but starting from the left to the right, our wing temperature humidity is our biggest seller. Obviously, space utilization is so huge today. Spaces are being used differently. Spaces are being reshuffled. The way people are sitting in spaces and using these spaces. Sometimes the mechanical equipment there they can't do it all for the entire building. So when they're going to have certain use cases of certain people in certain areas of the building, what they're looking to do is utilize different spaces better, because you can't just spend $1 million to redo the whole entire system, right? I mean, let's create a migration path. Let's create a starting point, right? What was the first slide? Leverage wireless as an opportunity to take an action, right? So let's create a starting point and a migration path and really understand what are we trying to accomplish with this data point. So, you know, obviously some of these areas are pretty obvious, right? I mean, data center cabinets, room temperature, humidities, even in air handlers and ducts. Warehouse space, storage is a big deal now. Cold storage too is growing in demand, obviously, with the need there. And underfloor monitoring, I just want to touch on that for a moment. Data centers are what's keeping our whole entire world connected. So, you know, we're obviously focused on the building, and we want to make sure that the building is effective and operating properly. But let's not overlook the fact that the data center has to maintain uptime 100% of the time. So we have a few different products inside of the data center market that help with airflow, like our Triad performance panels, and hot aisle and cold aisle containment. We have a variety of other tools as well to block air gaps inside of those spaces to really drive premium airflow, right? And our Wi-Fi, I'll touch on as well, is really cool because I just sold a job that went into a school. The school has walls that are probably 1.5 to 2 feet thick of concrete, and they're old buildings. So they can't run wire anywhere, but they already have existing BACnet MSTP control wire through all of the buildings connected to all the fan coil units. So what we were able to accomplish and validate is that our Wi-Fi times 87 rooms was able to go ahead and provide that data back up to the enterprise, which then pushed that data point down to each of the individual rooms to be able to control each room effectively without physically wiring a thermostat in each location. The thing I've also learned over the years is thermostats get locked out. There's a lot of pretend logic that's going on when you hit the up and down button. It's not really doing anything. So, you know, let's, if you can do it and you have a controller that's local and all you really need is that data point to drive the action inside of that control system, look at these two transmitters between the WiNG wireless TH and the Wi-Fi TH, right? And then the other big thing is status alarms. I know I've been in a variety of different buildings and they would just want to know when something tripped, and to actually run a wire all the way up and down and around to a control system, it's going to create disruption. It's going to create a lot of cost planning, all of that. Whereas what we're able to look at is ultimately, you know, pulling a tab, auto discovering this guy into the WiNG manager, and then driving the outcome. So some of the other good use cases for the digital input is with a current switch relay. I know when I was working with another group, one of the big things they bought a lot of was knowing if exhaust fans were on or off. So a current switch relay is going to measure that there's current on there, and it's going to stay closed to let you know that it is. And when it's off, it opens up so that now this is a point that you can now manage and help get a better understanding of exhaust fan utilization, right? A smoke detector is a pretty good example of that, as well as our power fail monitor. If power trips in a space, you need to know about it. You may not know about it because the building isn't quite as full and you don't have people complaining about it as much as they used to. And then we also sell a hydrogen and methane gas detector that you can set some thresholds on and trip that alarm as well to come all the way back to the WiNG as standalone alarm emailed out, just like anything you would hope, or it can be integrated back into your control system. Working with a few other folks, they've helped to identify that our WiNG Therm transmitter is really a great use for the pipe strap sensor to make sure that temperatures on these pipes are maintaining the desired temperature to ensure that you're really driving optimum performance with your boilers, right? And you want to alarm on that. And there was a unique application that actually used a WiNG thermistor with a 25-foot averaging sensor, 10K type 2. And you know, it was basically kind of a one-off, way off the charts application, but boy, did it work. It was exactly what they needed, and we were able to solve that problem. So, you know, walking with the WiNG RTDs, I think we've seen a lot of success so far with refrigerator freezer monitoring. The freezers obviously sometimes can get extremely low, so obviously you want to use some kind of a probe with a glycol bottle so you don't have these heavy swings. Great application for the RTD there. And then our WiNG spot and WiNG leak detection. This can go everywhere. Between data centers, hospital critical zones. I know we worked on a project where we put some leak detection over some MRI equipment, as well as some other areas and zones in that building. They had historically some sprinkler problems. So they had about once or twice a year, a sprinkler head would pop in one of their buildings, and they got fed up with it, causing all kinds of chaos and downtime and a lot of costs that you really don't want to have to deal with. But leak detection is also great inside of obviously any mechanical room. You got all your piping and all your valves and all your pumps and everything right there. So let's make sure that you're paying attention to that, because not everybody's always walking into those mechanical rooms. So we want to, ultimately the deal of wireless is our RLE wireless is to get data back so that a service group can do something with it. You know, cooling towers or other fluid storage is a pretty good use case as well. There's a group that I've been working with to basically provide 200 feet of sensing cable inside the the wall of a fluid storage tank. Probably didn't think you can do that or would do that, but that's a big challenge for them. They've always had a problem with that, that particular situation, and could never really find a good way to solve that. So, you know, we're looking at it and we're helping them out. And obviously, any bathroom environment, you got a lot of piping. Hotels have tons of that, as well as other environments. But then let's not also forget the elevators. A lot of these buildings have elevators, especially when they have multiple floors. They got hydraulics down in the floor, under the shaft, you know, for the elevator. Water is not good there. So, you know, there's a lot of ways to just drive some simple visibility and protection into those spaces. And then the one that I really get geeky about is our WiNG-ANLG. And the reason for that is because it can literally connect any 0 to 5 volt, 0 to 10 volt, or a 4 to 20 milliamp output of any sensor. You know, we're pretty excited about that one because it has so much potential to help in so many different ways. A couple of the most common ways here is with CO2 sensing, carbon monoxide sensing. We've actually successfully put a self-powered CT on the analog transmitter, so that we're also we're basically got wireless energy management strapped on anywhere to give you the data that you want. An industrial plant I was just working with as well just leveraged the analog with a float sensor. So they got these big tanks, and obviously when it gets below a certain point, they need to know about it so they can trigger an alarm. So, you know, a lot of good use case examples for that. The differential air pressure transmitter, building pressure. Today, it's probably one of the hardest things, and it's always historically been one of the hardest things to tangibilize building pressure. How do you make it known what building pressure is, besides putting a little tissue by the door or trying to open the door and it hit you in the rear on the way out or something, right? All challenges with building pressure. And today it's more important than ever, especially to keep contaminants out. So you want to keep a slightly positive pressure in those buildings. But again, coming back to the data center, we got underfloor monitoring. So we have an underfloor monitoring panel designed to hold our transmitters so that we can give you that data so that you can optimize system performance inside of there. I keep mentioning the data center, and I got an example on that, but it's so important. It's so important. I can't explain it any more than that. So the filter status, though, was another one. The guys who were building the healthy dashboard had shared with me that they wanted to put a differential air pressure tube inside of the area so that they know, you know, when is that filter getting dirty? When is it starting to get contaminated so that they can make a change, right? Filter status historically has always just been done monthly or quarterly, whatever your maintenance schedule looks like. But now with the need to create more fresh air coming into the building, the likelihood is that you're probably bringing in a few more contaminants than historically known. So the filter may need to be changed more frequently, but you don't know because you really don't know the pressure inside of that space. So that's something that we can deliver immediately. And then with our WiNG Air as well, something that, again, is so important is understanding the air velocity inside of these spaces. Could be the underfloor, it could be a duct. Ultimately, our goal is to help you identify these areas of opportunity and drive to the end result. Now looking at it from a variety of perspectives, sometimes it is a permanent install. But there's a lot of you service organizations and system integrators that are out there that just wished you had 10 points of data to help an end user understand what's going on in their building, or help your service organization understand what's going on inside of that building and that building system. And so, we've used our WiNG Manager a variety of times now with a variety of different partners to actually deploy as a service tool and a service kit. And I think that's so critical. And why is that? Why is any wireless important? Because you need the data. But the biggest challenge I've always seen, and I know I've talked to a variety of other folks about it, is that signal strength. How do I know I'm getting good data? How do I know that I placed it in the right space? Especially if you're using it as a service tool, you can deploy it anywhere. I mean, you can literally deploy, I've been in a building with 10 points of sensors and walked around the building, and in 20 minutes or less, put all the sensors where I wanted them, went back to the WiNG Manager, pulled it up, and came to this screen for the wireless network metrics. I wanted to see, do I have a good signal strength? Do I need to move something around? You know, where are the challenges? And, you know, with the 900 megahertz radio, I rarely ever have to go move anything around. And that's a pretty big pat on the back to Don and the RLE engineering team. So good job, guys. And, you know, so I just wanted to put this screen up here to validate, you know, that RLE has a built-in tool inside of our web user interface that's showing you the wireless network metrics to validate and ensure that you got a great signal strength. I get into this screen, which may look a little intimidating, but for a lot of the system integrators out here, this is just another day in the park, right? You know, so doing some level of gain and offset is common. And so we built the WiNG analog transmitter to be flexible. We wanted it to allow one transmitter to allow you to have the capability to connect any output from any sensor that's a 0 to 5 volt, 0 to 10 volt, or 4 to 20 milliamp output. So I put this on here because I don't know how many people really know about it and really get into doing this without physically connecting a wire to a lot of the sensors. So I just wanted to create some comfort knowing that, you know, we have a game plan, and every time I've used this, these equations for the gain and offset for the 4 to 20 or the 0 to 5 or 0 to 10, whatever was on the display of the sensor was now on the display of the WiNG manager. And there's just a little equation that you do, and then some jumpers on the transmitter to help isolate that. So I used the Wi-Fi as an example earlier in a school project, and this is basically what we did. We took our 87 Wi-Fi transmitters all throughout the building. Since we already had the WiNG manager in place and its dual function, we were also able to use some of the radio transmitters, the 900 megahertz transmitters, and put some extra differential air pressure sensors throughout the space. And then ultimately took that data to the WiNG manager wirelessly, pushed it up to the enterprise BAS, and then the enterprise BAS system pushed that data to all 87 rooms so that they had the ability to actually drive proper control comfort into each of those fan coil units in each one of those rooms. So great application. You know, it's obviously a permanent install, but it's wireless, so it could be moved around anywhere if the space gets reutilized in different ways as well, you know, and be added onto. So let's not forget to state that. You can have up to 400 transmitters on a WiNG manager when you add a range extender. Otherwise, out of the box, the WiNG manager can manage up to 250 WiNG transmitters. So you talk about scale. A lot of folks I've worked with start with 20 or 10 or 50, and then they end up growing it to 100 or 200 different transmitters because they can. So, you know, based on your environment, every environment's different. It works, and it works great. So I start getting into a few of these data center applications and different use case applications for the WiNG manager. I start with the data center again because it is so critical to all of our lives today. We as RLE historically, we have been a leader in the critical space and data center for leak detection, environment monitoring, airflow with the floors. I mean, you see all these perforated floors on there. I specifically chose this example because I wanted to state, you don't need all of those. They're only using all of these because it's an inexpensive perf panel, which is really causing, you know, insufficient airflow, and quite honestly, it's kind of a weird design. So you see some of the cabinets are off on some of the other floor tiles as well. So we have a hybrid panel too that is half solid and half vented, so that you can really take advantage of a secure area for the floor structure to sit on, or the cabinets, I should say, to sit on. You know, and with the WiNG temperature, humidity, these are going inside of data cabinets. They're going under the floor. They're going to help manage and optimize HVAC performance. We're also leveraging some of the WiNG digital inputs for status alarms, switch relays, and even doors. The WiNG Therm, again, a 10K Type 2, used it on a variety of times for duct probes, even pipe straps. And then obviously we're known for our leak detection. So let's not forget about wireless leak detection to be able to put into these spaces as well, as our differential air pressure needs to maintain certain levels inside of these spaces, as well as understanding air velocity so that you can really tune in system optimization for your HVAC equipment. With the data, you can now understand Do I need to create a new logic sequence, or do I look at putting in some triad floor panels to really improve airflow, or do I look at hot aisle and cold aisle containment so that I can really drive optimization, bring the temperature up into the space, and generate somewhere between roughly a 4% energy savings per degree increased in that space, and that's on that's on cooling costs, that savings, obviously. So in a campus environment, this is one of my favorite types of environments, obviously, because there's so much to look at and there's so many things that we can help with. We've already talked a little bit about the classrooms, but there's computer labs and there's boatloads of IDF and MDF rooms out there that are just disparate into these different spaces. I don't know how many folks I've talked to that they're there, but they don't have any monitoring in the space. There's water piping all around them. There's different areas that need to be monitored, even door contacts to know, is the door getting opened? Is it getting closed? Is it ever getting closed? There's other security measures, obviously, that can be taking place with card readers and all that, knowing that people are in there, who is in there. But you still want to maintain proper understanding inside of those cabinets, and again, kind of reiterating some of these use cases. But CO2 is so important. I don't know how many folks have ever been crammed into a classroom or some kind of a conference room, and there's too many people in there and everybody's exhausting CO2. And well, now today there's new standards that say, hey, you got to get that CO2 out of here and bring new fresh air in. Not that it wasn't there before, but it's more recognized today, and it's something certainly that you have to pay attention to with those different data points. And again, you have to have the mechanical equipment available to actually drive the result. RLE's wireless is a monitoring device. We're aggregating the data to give it to you, to alarm on it, to create an action, but you have to sit down and understand what's that action going to be, right? Take the time to understand that. We've been elicited by retail as well to help understand some of the different common spaces, and then some of the different stores inside of the mall. Some of them get packed and some of them need to have more air flowing than others. So we're excited to have that opportunity to make sure that building pressure is maintained in those retail spaces, because we all want to go shop. We can't always all buy everything on Amazon, right? Some of us like to do touch stuff and try it on and all of that. So, as retail shifts and the way that we buy and our buying habits all shift, space utilization is a key phrase that I had heard on another webinar with some commercial real estate folks, and just describing how the space is going to change. It's not changing overnight, but there's more thought being put into, as more people come back into these buildings, how can we use these spaces? And when we have to huddle up, are there certain areas of the building that might be easier to retrofit some equipment to allow some of that exhaust air and air exchanges to occur, instead of trying to do it in the entire building, right? Entering and leaving buildings has changed as well. So, but again, the big thing that I have to give kudos to my partner on is recognizing that filter status and the pressure inside of that filter is so critical. And putting that on a dashboard, I think is something that I think helps create comfort for the occupants. Healthcare is another big example that obviously we all have to have it, right? We're either need to have these healthy environments, and healthcare we assume a lot of times are safe, but they need more data sometimes. And as tight as the controls are and need to be, sometimes, let's just be honest, low bid won. And, you need more data points. So I had a good example the other day shared with me. We were looking at a job. This guy tells me we were looking at a job, and we added up all the costs to add all of these wired sensors and everything. But we were short maybe 20 sensors, 30 sensors that they wanted to also put in, but the end user didn't have the capital budget to do it. So what they did was kind of looked at what the sensors they were looking at were, where they were going, and how they can create a hybrid approach to actually give them the data they wanted for the same capital budget. So create that hybrid approach. Put some extra CO2, carbon monoxide sensing in there. Make sure you got your differential air pressure and statuses all throughout the building. You know, I know that there's a variety of different tunnels and bridges and all of that connect all of these healthcare buildings and around the different blocks. Let's make sure that we're really taking advantage of that, because, you know, one big group that I was working with had a bunch of bridges, and the pressure inside of these buildings, you know, if you got an airborne disease that goes around, all of a sudden, you don't know where it went. I mean, you got positive pressure here, negative pressure there. These bridges are all connecting. Airflow is all over the place. So you really want to be able to manage and understand those air patterns to really drive a safe environment for all of its occupants. And then the other big thing too, coming back to the thermistor with the pipe strap sensor, Legionnaire's disease. You know, there's a lot of these buildings that had water sitting in tanks for the last month or 2 months, worst case 3 months or more. But make sure that you're leveraging some of that water, risk mitigation plan to be able to ensure that water is being produced at 140 degrees and it's not dropping below 120. Industrial plants. This is one of my favorites now here recently, because we've been working with a big group globally to identify some of the different areas that they need status alarms on. They got a lot of equipment and it's all over the place, and it's got high ceilings and piping everywhere, right? They can't run wires everywhere. They just can't. But they're missing the opportunity to create efficiency and to create alarming. The one group had a system overheat, which caused all the air conditioning to turn off, which basically turned the plant down, and they didn't know it until too late. So that caused a whole big problem, and a lot of folks were really upset about it. And now they have some new status alarms with the WiNG-DI that are going to give them some more data to help them optimize that. And while also ensuring that temperatures and humidities are maintained. I think that's just as important as airborne diseases are killed with higher humidity levels. I think it's somewhere between 40 and 60%. So, you know, and then now the office commercial space. This is where I think a lot of the concern over buildings in general is going to occur. You know, commercial office space, we all historically got on a train, got on a bus, parked in a parking garage, walked into a building, got on an elevator, went to the 17th floor, never really thought twice about it. Well, now people are thinking about it. People may not be always going back to those buildings like they used to, or it's more of a rotated schedule. And, you know, now they got to get on elevators, which are limited to how many people can get on them. Now they're looking at elevators with ensuring they got exhaust fans in there to pull air out of that space to ensure safety and you know, remove some contaminations in there. So, you know, RLE, again, we're providing wireless technology that has the ability to do a lot if you think about what you want to do with it. You know, and I think that one of the best use case examples for this is all of the piping throughout that building, wireless leak detection. Let's put it in. It's easy to do. It's easy to connect. It's easy to manage. It's easy to alarm. WiNG in general is easy all the way around. And, you know, I'm a huge fan of it, and I think it just fits so many different applications. So again, let's pull it back to a service tool. If I had to make believe up an example of what a service tool may look like, if you bought all of these transmitters and sensors, let's just say, and this is just a random number here, you can have less, you can have way more. But I said, if we had this many sensors inside of a building, I'll bet you I can help identify more data in probably an hour than a typical service group that's trying to understand something that doesn't already have access to a control system. So let's leverage the data. Let's leverage WiNG Wireless to go drive an action. Let's start that first step forward to take an action. You know, I think that's the most critical piece, because you can't take a team of people into a building anymore. It's me, it's you, and that's it. And any technology that you have, right? So let's take the technology, let's deploy it, let's create visibility around it, and then let's start driving action to really improve system optimization. So what did we learn today? You know, RLE has an enterprise of different systems that can make an impact. And our main goal is to improve visibility and planning of the buildings, improve the airflow, building pressure, temperature, humidity, as well as indoor air quality. But again, you have to have other systems to drive how that actually is created and how that air is delivered to actually drive the outcome. We want to improve operational effectiveness and protect the critical zones that are driving a lot of the revenue for our organizations. And then, you know, really the end goal, let's be honest, we want to help contribute to the safety and health of the building and its occupants. And I say you can make a difference because I think a lot of people think wireless can be tough and challenging and scary. But, you know, with the wireless network metrics that are available in the WiNG Manager, the ranges that are available, the different points that you can look at, I think you have probably the best opportunity here with WiNG Wireless to deploy any kind of a service as a service tool or a permanent install to save money, to drive a result, and to really make a difference for yourself and the organization. So thank you for participating with the webinar today. I'm going to see if I have any chat questions or anything like that, and then we'll go ahead and get rolling. So one of the questions has come up. Why is the battery life? Why do you say the battery life is up to 12 years when no other wireless transmitter can do that? Well, it's a proprietary signal that we've designed to be able to take a small data packet, pass it wirelessly, and not take a lot of energy to do that. And that's why we're able to also communicate. That's the other big thing. That's why we're also able to communicate every 10 to 20 seconds. So wireless historically has always been a timed interval. The WiNG Wireless is an interval that's 10 to 20 seconds typically in a random fashion, and it's sent out with great range and discipline. So, you know, that's why we're able to have up to a 12-year battery life. How can I get a demo? Great question. Contact your local partners, your distribution partners, or you see my contact info here, or you can contact sales or support or your other account managers here with RLE. We'd be ecstatic to help in any way, and certainly appreciate your time today. So I think if there's other questions that I did not answer, I'll certainly make sure they get answered when we send the recorded video link out. But certainly, thank you all for your time and attention today. Appreciate your help in wanting to drive the desire to do wireless. I think it's so cool. So keep up the good work. And let me make a final note here. Thank you to all of the HVAC service technicians and engineers that have helped to keep the buildings and everything safe. You've all been amazing in your efforts, and certainly appreciate everything that you've done. So keep up the good work. We'll talk to you soon. Have a great day. RLE rules.